So now let's start off with the basics of Unity before we get started any further. I'll create a new Unity project and we can go through step by step. So first we go to Unity Hub. Opening. So we'll create a new project and we'll call this from a 3D basic core, and the project name we'll just call it MasseyHacks JumpStart, or just game dev tutorial. It's called game dev. And then sure, we can just create the project here. And okay, so it's right now opening it right now. So just give that one moment, and then in the meantime, I can show you actually the basics of the Unity editor from the screen here. So what we see here is this is a basic Unity editor, and your window will actually look something like this. You have your hierarchy here, your scene, game, project, console, inspector. So these are all the tabs that I'm saying. So this is scene, this is game, this is console, project, hierarchy, and inspector. So normally, this is the default basic layout that Unity gives people, but as you go through, different Unity developers will have different layouts that they prefer. And I think through my experience so far, the one that I prefer right now has me able to access both the game and scene tab at once. And that just helps me like able to see what both the player sees and what's actually happening in the scene. So the way I can like edit the layout is I just quickly to do like how I usually do it is I use the four tab, like four split layout. So I go here, four split. And here, this is like a good editor actually for like those who are working straightly on like editing environments or scenes. So that'd be the 3D word in the actual game. But for us right now, I think it'd be better just to get a scene and a game tab. So how I do that is I just do add tab game, and I close this tab, and I quickly add one more window, and that's from window general console. So the console is like what's printing out. So if you guys have done like Python or any other programming language, you will see that you know how you like print stuff out to console, like for example print or console.log or I don't know, scanf, printf. So you see that this is where all like the errors and log messages will be printed. Okay, so now I hope my second Unity project has opened. Okay, let me just close this one. Okay, yeah, here we go. So this is the default Unity scene. Again, I'll just quickly go to layouts. So you see that I've actually saved the layout that I just created as my layout, and that allows me to easily switch to that. And you can easily do that for yourself by doing layouts, save layout, and then you can add a name. So I already have one. I'm not going to save it again, but yeah, that's how we could do that. Now let's go deeper into the actual components of this Unity. So we see that we have a hierarchy, and we see that right now our hierarchy has two things in it. It starts with the main camera, which is right here. And what that is that's what you can, like, that's actually the viewport of what the client sees or what the player playing the game will see. And then there's also a directional light just to give the scene some lighting component. And just in case, like to navigate this, you see that when I double click on something, it becomes focused in my scene. And like you can just quickly right click to like rotate your scene view. So you see that I'm like going in between, like you can see the axes at the top. I'm like moving like the rotation of the scene, you could say. And then you can like middle mouse click or like click on this and then move. So like click on this, then move. You can pan through the scene. And then like you can rotate objects as well as scaling. We'll get to some of these later, but I think first, in order to see what's actually happening in the scene, we need to first create a 3D object. So this is how you can create basic objects in the Unity scene. You just right click on your hierarchy and you click create 3D object. And for this tutorial, we'll be using a capsule. So we'll just create a capsule quickly right now. And we'll also create the ground for our capsule. So that would be like the plane. And we'll just put this at like let's zero our capsule position. So you see that our capsule actually has something called a transform. And we're working in Unity, which is a 3D game engine right now. Like that's the setting we set it to. So it gives us this in 3D space. So this is the x-axis, the y-axis, and the z-axis. So in 3D space, we're gonna like to do everything like we'd start with the origin at first, but this you can see is like the position. And we can move this plane up, down, right, left, and that would give us the position. And like you can see the transform is changing here, right? So this is the position in the X, this is the position in the Y, and this is the position in the Z. So for right now, we'll just do 0, like -1, 0. And now you see like from our camera's point of view, like our camera is facing in this direction, and what the main camera sees is exactly what's going to be in our game. This is where our client's going to be. And um so now like if you can actually see that I can rotate using right click, and I can actually zoom in through the scroll, and then finally I can like pan using the pan tool. Yeah, so this is basically how you move around in Unity, and we can start getting into a bit more of like making this scene not so monotonic. So let's now look at this project window down here. Right now we have a sample scene, and that's what we're going to be using most of this tutorial on, basically all the tutorial on it. But you can create your own scenes in other games and actually transition between scenes. But for smart projects, and I think even the one you'll be submitting for the game jam, that yeah, so even the one that you'll be submitting for the game jam, that you just need one scene. So for now, we'll just work with this one scene. And basically, assets is everything that we have in the project and like what we're working with. So what I'm going to do is I'm going to create a new folder, and I'm going to call it materials. And one big thing about Unity is keeping like your directories and materials and folders clean, because Unity uses your directories for programming, for resources, for a lot of different aspects. So having a clean directory and like file management system is very important. So just to get rid of, like just to add some color to the scene, I'm going to start by adding like a new color. We're going to call this ground. Oops. Rename ground. So, and then what we can do here is we can actually change this color to like, maybe we want something like grass, right? And what we can do is now say I want to add this color to the scene. All I have to do is drag it onto the object I want in the scene. So say I want it on the ground, I drag it there, and now we have this color. Now maybe I want it a bit darker. You see, I can change the color and see how it affects my scene. And this is how it would affect, like how it would actually look from a player point of view, which is the left corner. And then maybe we want to also create one other material for like the player color. And then here we would like maybe add a blue, like maybe a light blue. And we can see that we can now add this to the player. And now see our player is a light blue. So this is how you can create easy objects. You create objects here, and then we have our capsule, which is going to be our player object. And we're going to rename our plane to be our ground. Yeah, and then this is the basics, like how to navigate. You navigate in the scene using these tools. And like you have more tools, like for example, this one. This is just more for 2D UI, but you can see that we can stretch this in a 2D plane. And then we have the scale. So this scales it up. So for example, on this object, we could scale it in like different directions. And then finally, you have your rotation object. Let's say you want to rotate the plane, right? You could rotate in any of the 3 axes. And as you see, this is also can be done just by editing the transform values here. So far, so good. Any questions? Let me admit everyone who's still joining. And then, yeah, so far all we've learned is to add objects and add materials to the scene. And then we can see that in the game. And I think now we can actually start getting into the actual components of our player object. So we see that this has a capsule collider. And if I click play, oh, wait a minute. So nothing has happened right now, but let's see what happens if I add a rigid body. We're going to be using a lot of rigid bodies today. So I want to show you the aspect of a rigid body because this is how we'll actually be able to use physics. So you see, that was a bad example. But if I increase the player object at a certain height, since I added gravity to this player object to the rigid body, oh, I moved it. But if I add a rigid body here, and I add use gravity, then I click play. We see that this is the object and it actually follows using gravity. And in fact, this rigid body is what we'll use for most of our physics and even our movement going forward. Let me see how much time. So I think now I can actually get into a bit of scripting if everyone understands like how the basics of creating objects and adding materials. Okay, let's get into creating our first script. So we want to actually be able to make this capsule actually move through input. And how we're actually going to do that is we're going to add a script component. And the first thing we're going to do is actually we're going to make this player object like complete. And how we're going to do that is we're going to create an empty object and we're going to call this the actual player. And we're going to child this player object to the player. So what I just did now is this hierarchy is like a tree. And I'm not sure, like for a tree, what happens is we have a parent, that's this player. Then we have a player object. And then we have that's underneath it as a child. And we can add more children here. So I'm going to actually do that here. And we're going to create empty. And we're going to call this orientation. This is going to be used for like when we want to rotate the first person, like camera direction. So that's going to be in the y-axis. And then we're going to also add the main camera straight under player. And the reason we're doing this is in a first person like game, the main camera follows the player. So what we actually want to do is we want to make our first person. Okay, that's why. This needs to be 0, 0, 0. Oh, and I see that. Oh, I'm in play mode. Nice. Okay, so this player object is at 1.6. Let's put it back to 0. And then what we're going to do is we're going to create an empty of the player one more time. Oops. We're going to add the player object onto the player, and we're going to add the main camera onto the player, and then we're going to add the orientation. And this is just helping us get our player hierarchy set up so that we can actually use it for our code. And then what we see is we want our player to be, let's say at 0, 0, 0. We want our player object. So our player object is no longer going to have the rigid body. It's going to be on the player. And we're going to add, this can be at 0. So we want to 0 all these positionings. And the reason we're zeroing them is so that it makes it easier for us to actually like change the positioning relative to the player. So what that means is if we move the player object, so right now, you see I'm controlling the player object. See how the camera moves as well? That's because the camera is a child of the player. That means that it's dependent on the transform of the player. So what happens is this transform is not the actual true positioning of the camera. it adds on whatever its parent's transform is. And that's why whenever you move, it moves along with its parent. So for us, I think this main camera is a bit too high. And we can just change it to like, let's do like 0.05 or 0.5. This looks good. Something like this. So now you see that our main camera is like in our center of our keyboard. It's moving in one place. It's moving like it's facing one direction. And this is like our first person controller. And this is our hierarchy for now. So now we can actually create our scripts and start actually moving this capsule. So let us start with that. And we want to also make sure our directory system is clean again. So we add scripts to a folder called scripts. And this script folder will then hold another folder for our player scripts. And then we're going to create a new C# script, and we're going to call it player camera. And now if we click on this, it'll open a VS Code coding file. And in this script, let me just, oops. Okay, so we see that we have two files here. Yeah. So we have two functions here, start and update. So a start, these are the two basic functions in every Unity script that's mono behavior. And what happens is the start is called at the very beginning. So like again, at the first frame update. And so as an example, what I can do is I'll console.log or debug.log, sorry. Unity script, Unity start, and then our debug.log here, Unity update. And then using this, we can actually see exactly when the scripts are called. And we can look at our console for the first time and see how our console makes sense. So the first thing is for our player camera, we have to attach it to something in our scene to actually make it run with the scene. So I'm gonna add it there, and I'm gonna click play. And now it's loading the script assemblies. Okay, and now if I switch to the console, so you see that player Unity start got called once at the very start when I clicked play, and then now player updates being called every frame. So that's just one idea of how like the start and update works. So now we can actually get into our player camera and how this would work. So let's think from an FPS standpoint point of view. So for now, I'm just going to delete these so we have a complete from scratch. What we're going to do is we want to have a mouse that like rotates, right? So what I'm trying to do right now is we have a camera and we want to be able to like look around in our world. Like right now, you saw that nothing happens. Like none of my input is actually affecting the game. And that's a pretty bad game, right? It's basically just a picture. So, to start with our first person, we want to first allow the player to actually be able to look around, like by the mouse cursor. And what we need then is, I'm sure that in your games, every game has some sensitivity for the mouse X position and some sensitivity from the mouse Y position. And this is often like able to be changed by like the player, the client. They can change like the sensitivity of the mouse, make it higher or lower, and that'll just change how the game inputs it to their scripts. So then we also want to actually take in our transform orientation that we added. And then we're going to have like this will help us actually change the orientation of the player. Then we're going to have a private float with the X rotation and Y rotation. And this will just be local variables that we will use to calculate during every loop. So now let me go into specifically what these transforms and floats are. So floats are like decimal point numbers that are used in Unity, and public and private are scopes. So what that means is, like, for a public scope variable, it means that things outside the class and basically just outside the class can edit and access the variables. And private floats just mean that only things within the class can edit and access these variables. And what I'm saying here is I made these two public because, like, people can choose to edit their sensitivities, as well as I made this public so that I'd be able to actually reference it from my hierarchy, and we'll see that soon. And now we should actually add back the void starts. So again, the start script function that we saw before. And the first thing we want to do is we want to change the cursor state to be locked. And we want to change the cursor visible state to be false. And finally, let me just add the update function. So this is where we want to actually do the look around. And how that works is we get the mouse. This is where we get our input. And to get the input, we need to have something like this. So what this does is it gets the motion in the horizontal direction of the mouse. And what we need to do is we multiply that by time.delta time. So this gets it over time. So how much do they actually move their mouse during, like, delta time is the change in time from this frame to the last frame. So if they did a large motion over a small period of time, this will keep that into effect. And then we need to also take into account our sensitivities. And then we do the same thing for a Y. So now that we can get the mouse Y times time.delta time times sensitivity of Y. And then we get Y rotation. So now we just want to add to our Y rotation the change in mouse X. So now let me explain what this even means. So when we move our cursor in the X direction, which we set as the horizontal direction, we want our character to move along the Y axis. So this is the Y axis, right? Like, the vertical axis of our character is the Y axis. So when we change the Y rotation, we see that our character actually, like, our camera moves in the X direction, right? And that's why we change our Y rotation dependent on our X movement of the mouse, because of this rotation changes, like, the horizontal rotation, the vertical rotation. And finally, we want the X rotation, and we subtract for the X rotation the mouse Y. And the reason is when we rotate upwards, the way, like, let me show you. If this loads. Okay, so when I rotate this in the positive direction, we see that we're actually looking downwards, right? And when I rotate in this in the negative direction, we're rotating upwards. That means that the X rotation should be inverted, because if we go down, it's positive, and if it's up, it's negative. So that's why we need to, like, subtract from the mouse Y. And then what we need to do is we want to make sure that our X rotation has clamps, right? We don't want to be able to just continuously rotate up or continuously rotate down. So what we do is we do a clamp, and what this will do is it'll, like, clamp this, like, the value we give it, we want to only rotate upwards 90 degrees and downwards 90 degrees. And then finally, now we can actually change our transform. So what this command does here is it gets the position of the current transform. So you know how we attach this script to the camera object? It'll actually get the camera's transform position. And now what we do is we do transform.rotation equals. So they use quaternions for rotation. So there's actually 4 values, X, Y, Z, and alpha. But we can just convert our Euler angle, which is X, Y, Z, to a rotation object. That'd be like this. So we just send in the X rotation, the Y rotation, and really we have no Z rotations because a Z rotation would look something like this. I'll show you. Oh. So I don't know if you were able to see it there, but I think if you see it like this. So you see, I'm like, the Z rotation is the angle that like makes it wobbly, right? And most games, you don't actually just change this rotation at all. So for our game, we also won't be changing this rotation. So that's why we just set it to 0. And finally, we want to change. So the orientation dot rotation again is an object that we use specifically for the Y rotation. And this is actually going to help us in the future. So we have something like this. And the reason we have this orientation is for some objects, for example, the gun we'll add later in this video, we only want to rotate the orientation. Like we only want to rotate the character by the y-axis. And we don't want to actually like make our object go up and down with our up and down head motion. So the orientation only takes into account the y-axis rotation, and that helps us like add objects to our characters, add skins, add items, because the items usually are stationary and locked in with respect to the up and down motion. I'll explain this a little later. Let me just see what this error is. Oh, there should be rotation. We're only dealing with rotation right now. So let me just show you, and then we can explain the code step by step. See if we can actually be able to look around. Oh, orientation. Okay, yeah. So this is what I meant by referencing. So when I go to main camera now, we see that our sense X, sense Y, and orientation are like really off. Let's just make this 0.5, 0.5. And our orientation, we need to actually do a reference from our hierarchy here. So that's the error here, unassigned reference assumption. I gave a reference, but I didn't like actually assign it in my hierarchy. So now if I click play, and also clear this, we see that the game's working. And I think my sensitivity might be too low. One moment. Oh, this script should be on the player object. Wait, I think my sensitivity was too low. Let me add the orientation and click play. Okay, yeah. So now you see that we're actually able to look up and right and left, right, through our cursor movement. And I should actually increase the sensitivity a bit more. Yeah, so like depending on your mouse, you might have a different cursor. You might want it to make this like a bit bigger or big smaller, depending. See, so now it's much more sensitive, right? And now you see you can actually look around in our world. And also another thing is you see the cursor is no longer there. So like in most FPSs, you don't have a cursor. But if I click escape, the cursor is back and I can now stop and play. So this is how the rotation works. And this rotation script all goes off this player camera script. And we see that what it does is it changes the transform.rotation. So I didn't know if you guys were able to see, but this rotation actually changes, and that's due to the script. So one more time. So you see that this transform.rotation is changing. And also if I click on the orientation, you see that this orientation is like simply mapping this -87, basically. And that means that the orientation is just looking at the y-axis. And that's why we have the transform.rotation that contains the x rotation and one that only contains the y rotation. And that's why, and these two, so this edits the rotation of the object that this script is attached to, and this edits the rotation from the reference I got through line 8. And so this reference is from this orientation, so it changes this rotation.y, and it changes this rotation right here through the transform.orientation. So that's exactly how these two lines work. And the calculations just are how we get the input from our mouse cursor, and that's how we are able to move up, down, left, and right, and actually look around the scene. So any questions so far? Okay, so I've seen no questions so far. I'm going to assume that that means I'm a great teacher and not that there's some technical difficulties and I have no idea what's happening. So let's continue then. Now that we have the player rotation down, like our look around down, we actually want to be able to move our character. And how we're going to do that is we're going to add a player movement script. Yep. And we're going to actually add the rigid body back here. And we're going to be able to use this rigid body to make our movement much more clean. And let me make this ground a bit bigger so that when we do our movement, we aren't so constrained. Okay, so now in order to do our movement, again, since Unity is a game engine, we will need to resort back to scripts. So what we're going to do is we're going to create another C# script. And we're going to call it player movement. Okay. So now, while I code this player movement, the one thing I want to keep in mind for our coding, not just Unity coding in general, is abstractions. So for Unity and a lot of coding engines, it's very important to abstract like your functions so that it makes the code more readable and easier like to change in the future. For example, like I'm going to like originally all of the code is going to actually stem from the start and update function, but I'm not going to put all of the code in the start and update function. I'm going to call like functions from the start and update that make the code more readable, and you'll understand once I start coding this a bit better. But first let's get our actual requirements. And I'm going to introduce this header function. And what this does is it actually gives titles to our references. So we see here, we have no headers, right? We just have the variable names. By adding a header, it actually add a header here that allows us to like give descriptions to what this is. So it's like an useful comment for a header because people can actually see this comment. So it's like a public comment that people will see. And for movement, we have movement speed. And we're going to also have our transform orientation. So remember, we need to keep in track our orientation. So now before we start that, we want to get the private floats for horizontal input. So that means this is not the same horizontal as the cursor now. This means like the movement horizontal. So we're going to be using WASD. So that means A and D would be our horizontal movement input. And then we'd also have a vertical input for for our like W and S. So this will get us to move like forwards, backwards, left, and right. And then finally, we'll have our private vector 3. This will be our movement direction. And we will get our rigid body. So we're going to use our rigid body to actually make this code like much more clean. And first, in order to get our rigid body, we need to do a get component rigid body. Okay, so what this does is it'll get the component of a rigid body attached to the object we have right now. So we're going to attach the script to the player. And what it will do is it'll get us the rigid body and allow us to actually change parameters of the rigid body. For example, let me go here. You see our rigid body, we have info. It allows us to look at the speed, velocity, angular velocity, inertia, and basically do physics with our object. So now we also want to freeze rotation because we don't want we've already accounted for our rotation through our player camera script. So we want our motion script to be completely separate from our rotation. So what we're going to do is we're going to set freeze rotation to equal true. And that's all our start really needs. And then finally our update, what we're going to do is we're going to have an input. So we want to actually get the input. And for now, that's how we will abstract our function for now. So we're going to make a new function called myInput. And all this will do is get the horizontal and the horizontal input. So we need to get our horizontal input, and that's how we get it. Again, we do the same thing, except before instead of we did mouse X here, but since we're not getting it from mouse, it's just the horizontal movement. We get it from horizontal. And the reason we use horizontal here instead of specific keys, like we could do like a key code and get A and D and S and W, is that we want our like application to be as flexible as possible. So if someone wanted to use like a game controller, for example, Unity automatically maps the horizontal and vertical components to like the joystick properly so that people could change like their controllers and still be able to use the application. So then let's also get the y-axis. And finally, okay, that's all we need for input. And then now we just need to do a move player script. And that'll actually move our player forward. Just give me 1 sec. Yeah. So we're going to have a void move player. And we're going to do move direction. This is where we set our move direction. And we're going to use our orientation. And this will get the orientation's forward direction. We multiply by the vertical movement. So what this means is that if you're going forward, like vertical is like W and S. That means if you're going vertical, like if vertical movement is true, that means go forward. And also, this will add strafing. So what we want is orientation dot right. So now, based on our orientation, the right direction, we want to multiply by the horizontal movement. And that gets us our actual direction, right? Like we get forward times, like if we are going forward, backward, it'll be backward if it's D, because vertical movement will be -1 in that case. And then you also add your right direction. And then finally, all we have to do is do RB. So now we have to use our rigid body to actually add this movement. And what we'll do is we'll use a new concept here called force. So I don't know if you guys have learned in your physics class, but you have forces in like objects in physics, right? And what this rigid body will do is add a force to itself to actually make it move in a direction. And what we have here is we can now add the movement direction. And we want it to be dot normalized because we want it to be the same magnitude no matter which direction they're going. And we want to times it by the movement speed that we had, that we defined before. And we're just multiply by 10 so that like it'll go a bit faster. And then we do force mode dot force. And this will give us a force, continuous force on this rigid body. And now the last thing that we need before we can actually start testing this would be the fixed update. So this is another function, much like start and update, that Unity internally carves. And the reason we use fixed update is because we want to only like start moving and adding the force after we get input. And this occurs after update frames on every computer, as well as it occurs like regardless of FPS. So that means that if someone has a faster computer, they won't be moving faster, right? And that's the very important thing. Like in games, just because someone has like, I don't know, like a Ryzen 7 core GPU and like a huge system, it shouldn't mean that, okay, they're going to be moving like 10 times the speed I am in the real game. And that's why we use fixed update, because it'll be the same regardless of inputs. The only thing is a person with a faster computer will be able to do like faster inputs, but they won't actually move faster. It'll just be like their like reaction time would be a bit faster because they can see more, and that should be expected. Okay, so now let's actually go back and see how this works. See what changes we will need to do. So I think we have 2 minutes left, so we'll just get this script working and then we'll come back and fix it in the next session. So we see that we have sense X, so we'll make this like 10, 10, and we need to add the orientation. So the orientation's here. We click play. Oops, I added the wrong script. Move component, we add play a movement. Make it like 4, and we add orientation. Okay. So now you see that I'm moving around. So the one thing that you see there is that our character now goes super fast. And this is not a movement speed thing. This is a physics thing. And the reason is, like we move, right? And like it's really slidey because every time we add a force, there's no like slowing down anymore because that force is the only thing that's being added to our rigid body without any drag or friction or anything like that. So if you wanted to make like a really fast character game, then yeah, maybe you could do like Sonic the Hedgehog thing here. But in the next session, we'll look at how to add like friction, drag coefficients, and like even some jumping mechanics. Again, if you have any questions, please feel free now. Otherwise, correct me if I'm wrong, Lily, but I think they have a 30-minute break now.
Yeah, they have a 30-minute break, and I also just sent the points code in the chat, so you guys can put in the code in Discord and earn points for attending this workshop. And also, if you guys have any questions, just send them in the chat or unmute, and Anish is here to help. Other than that, yes, everyone has a 30-minute break, and we will be back for the next workshop at 2:30.
Yeah, and last thing also, I think we should like, did we send the doc link? Do they have the lesson plan?
Not yet.
Okay, I send the lesson plan link in the chat that you guys can follow along there as well.